Right, good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pakama Research and Development. You may WhatsApp us on this number 063 629 3655. 063 629 3655. Right. Today we're going to be looking at one of the topics in paper 2, which is the circles, angles, and angular movement. This is part 1 of that lesson, and next week we'll do part 2 of that lesson. So in part 1, we're going to be dealing with the following. By the end of this lesson, we want you to be able to do the following. You must be able to do the conversions. Now, when looking at the papers that we have done previously, papers that the learners wrote last year and the previous years, we realized that most of the learners are struggling with conversions, how to convert. Going to look at that part of conversions because the diagnostic report talked about learners unable to do correct conversions. So we're going to look at those conversions, and today we need to understand how to do those conversions. Number 2, we need to look at the following formulae and be able to can apply them successfully. The formula for the area of a circle, because we're going to be working with a circle most of the time. The area of the circumference of the circle, we're also going to be using that formula. The S here, it is the arc length. So we're going to be looking at the terminologies of those circles and put those those signs there, those symbols there. So you'll see what that symbol stands for. So the S stands for the arc length of the circle, and the R there is for the radius. And the theta there, it will be for the angle in radians. Remember, in circles, angles, and angular movement, we're working with radians. The next formula there, it is for the area of the sector. This is the formula that we're going to use for the area of the sector. There's another one that we're going to show when we're doing this, when we're doing activities there. The last one there, finding the area of the segment by using the area of the sector and the area of the triangle. That's also one of the things that we're going to be doing. So how do you find the area of the whole segment? So by finding the area of the sector and the area of the triangle. So these are some of the things that we need to know. Right. Let's look at conversions. The following conversions are very necessary in this topic. But first, let me address this. The conversions that we have done in grade 10, those conversions where you take in the centimeters to meters, the millimeters to centimeters and all that, those are very essential. But in this lesson today, we're going to be concentrating on the following: how to take the degrees when we have degrees to revolutions, because we're going to be working with revolutions. Now, revolutions, you've done the revolutions, it is the whole, if I'm talking revolution, that's what I'm talking about. So the whole is the revolution. So that in a circle, it's one revolution. So a circle is one revolution. And we're going to take now degrees. If I've got a degree, say for instance, I've got something like that, and I've got some degrees here. How many revolutions do I have? And that's what we're going to be talking about. And also vice versa. So we're going to take this one there also. If I've got revolutions, how do I then take them to degrees? The other ones, so revolution to degrees, minutes and seconds. Remember, this is also very important. How many seconds do we have in a minute? How many minutes do we have in a degree? And all that. The last one that we're going to be looking at is degrees to radians and vice versa. Remember, we said we are going to be working on radians, but sometimes we are given the degrees. We need to change those degrees to radians. So we must know how to change degrees to radians and vice versa. And we're going to look at the formula that we're going to be using to change degrees to radians and radians to degrees. So these are all the conversions that we're going to do. Added to that, as I said, your millimeters, your centimeters, and all that, you need to know those. Right. Now, let's quickly look at the activities that we're going to be doing under the conversions. The first activity says determine the number of revolutions. So you can see now we're talking about the revolutions. What is given there is degrees. So I'm given degrees, then I must change them to revolutions. So as I said, one revolution is 360 degrees. So I'm having 60 of them. So in other words, I'm having 60 degrees, but I want to change them to revolutions. So what do you think we must do here? We have got a 60, it's in degrees. We are saying one revolution represents 360 degrees. Now 60 degrees will represent how many revolutions? So now if we can just quickly do that, we can say one revolution represents 360 degrees. So 60 degrees will be represented by how many revolutions? Okay, so you can see in this case, if I cross multiply there kind of and then do that, then I'm going to have x multiplied by 360 degrees. It's equals to 60 degrees multiplied by one revolution. Okay, so now then I divide both sides by 360 degrees, right? Which means that my x is going to be, the degrees will cancel out. I'm left with revolution. And now if I divide 60 by 360, the answer that I get there will be 0.167. That's revs. So that is revolutions. So you can see, what is it that we needed to do there? We did not need to do all this working out. And the easy way of doing that will be to say 60 degrees divided by 360 degrees. And that's all that we needed to do. And the answer there will give us 0.167 revs. Okay, so now, if I've got degrees and I want to change them to radians, I just divide that by 360 degrees. So rather than doing all this, so you can just go to that and do it like that. So you can take degrees, just simply divide that degrees by 360 degrees. So the next one is going to be easy now. We're not going to go through all this working out. We can just take the degrees that has been given and we divide this by 360 degrees, and the answer there, if I take my calculator and say 333,5 divide that by 360, then what am I going to get? Then I'm going to get 0.93 revolutions. So in other words, I only have, if I'm talking revolutions, so I'll just have 0.93 revolutions. You can see if it's 333,5, which is much closer to 360 degrees, you can see even the answer that we got there, 0.9 is very close to 1. Because if I round that off, I'm going to get a 1. Okay, so therefore that can be correct. So we can see this one is very far away from 1, 0.1. So you can see that it's a very small angle and it's very small revolutions there. Right. So this is how you change. So if you're given degrees, you want to change them to revolutions, you just divide that by 360 degrees, then you get the revs. Okay, so given the angle, I can be able to get revolutions. So there will be questions that need revolutions, I think in part 2, where you're given an angle and we need a revolution. So just change that angle to revolutions by dividing by 360 degrees. All right. Okay. Now let's look at that. So it means that you need to go and practice, get more angles, put more angles there, divide them and see what you get. Now let's look at this. Express the following revolutions in degrees. Now you can see I'm given revolutions. Now I want to express them in degrees. Remember in the previous one, what did we do? We took the degrees, we divide them by 360 to get the revolutions. Now I'm given revolutions. Now I want to change them to degrees. So what do you think we must do? The opposite of what we have done in the first one. So in the first one, we divided by 360. What do you think we must do in the next one? We're swapping that. So we need to then multiply by 360 degrees. So I'm going to have 0, 0.6 multiply by 360 degrees. So that's what I'm going to do. So I take the revolutions and multiply them by 360 degrees. So if I multiply the revolutions by 360 on this one, I'll get degrees. So I'll get 216 degrees. So that's what I'll get. So if I take 0, 0.6 and I multiply it by 360 degrees, I'm now going to get the degrees, which are 216 degrees. All right. The next one, I'm going to give you a minute, only 1 minute, to complete the next. All right. I hope you did not struggle with that. And remember, the mark there is only 1 mark. So now let's look at 0, 0.24. We gave you enough time to go to your calculators and try to get your answer. Remember, you can send your answer to 063 629 3655. So if you send your answer there, then we'll be able to can check if you are correct or not. Now 0.24 revolutions, remember revolutions are given. What do we do with the revolutions? We take the 0, 0.24, then we multiply that by 360 degrees. Then we go to our calculator. Then I hope and trust you got 86.4 degrees. So that is the number of degrees that we have in 0, 0.24 revolutions. So we've got revolutions and we need to find the degrees. We just multiply by 360. These activities are very important. Remember, in your question paper at the end of the year, you're not going to be like asked these questions like this. So remember, you'll have a question. We'll have a question on that. Then I'll show you what you're supposed to do then. You'll have a question in context to say, if you have got this, you're given the revolutions. Please, at the end, they will say, give your answer in degrees. So you must be able to know how to change it. If you're given a question and say, these are in degrees, you must change that to revolutions. Then you must know what to do to change those to revolutions. Okay. Right. The next activity on conversions again. See, I'm doing conversions because, as I said, most of the time when we were marking, we see that learners are unable to do conversions. So this is very, very important. Now with this one, the radians to degrees, also very important. When you do it questions, you'll see, exam questions, you'll see that how do they ask this question. Convert the following radians to degrees. Now you've got 1 radian. So 1 radian is given. And you want to find out how do you change the radians to degrees. Now, to convert that, I've given a table there. You can see the table at the bottom there. If you're going to convert from degrees to radians, we must multiply by pi over 180 degrees. Okay. If I want to change from radians to degrees, then I must swap the 2, and then I must multiply by 180 degrees over pi. I'm going to show you this. So I've got 1 radian. So the radian is given. I want to change that radian to degrees. So how am I going to change the radian to degree? So I'm going to say, remember, I'm changing the radian to degree. So I must multiply by 180 degrees over pi. So I'm going to say this one is going to be multiplied by 180 degrees all over pi. Okay, so how do I then get the answer there? I'm going to say 1 multiply by 180 degrees. I multiply 1 by 180 degrees and divide that by pi. So if I go to my calculator and say 1 multiply by 180 degrees and I divide that by pi, then the answer that I'm going to get there is 57.29 degrees. So meaning that here, if I want this in degrees now, I'm going to have 57.29 degrees correct to 2 decimal places. Okay. Now I've got pi over 4 radians. So I want to find how many degrees will that be. So what should I do? I do the same there. I multiply by 180 degrees all over pi. Nice, yeah, because the pi and the pi cancels out. So I'm just dividing the 180 degrees by 4. And obviously that will be easy for me. I'll get 45 degrees. So the answer there will be 45 degrees. So the pi and the pi cancels out. So in other words, a quarter radian is going to be 45 degrees. So if I've got a 0.25 radians, I'm going to get, remember there will be a pi there. So quarter pi radian, so it's going to give us 45 degrees. So that's quite easy. It's 1 mark. So to change that to that is 1 mark, and we need that mark. We definitely need that mark. So to changing those conversions are very, very, very important. Now let's get to the last conversions. In this case, is the opposite of what we had. You're given a degree, you need to change it to radians. Very important, because most of the time in the questions in the exam, you are given the degrees, then you must always change them to radians. You'll see when we use the formula that the degrees will be given, then from the degree we change that to radians, because all the answers should be in radians in the case that we're going to be in activities that we're going to be doing later on. Now 214 degrees, we need to change that to radians. Remember, these are degrees now, it's given. We're changing that to radians. So what should we do? We multiply by pi over 180 degrees. So you'll see that it's going to be multiplied by pi over 180 degrees. So you see the degrees and the degrees are dividing, then you multiply that by pi. So if I work that one out, 214 degrees multiply by pi over 180 degrees. This is not 188, it's 180 degrees. Then the answer that I'm going to get there will be 3,74 radians. Okay, right. So for 214 degrees, getting into radians, I'll get it there. So don't confuse this with your revolutions and that. This is degrees to radians. So you must read the questions. The question will say, convert the following degrees to radians. Then you must do that. Then from there, remember when we're working with, as I say, in activities, the theta that you get, that we're given, you must change that to radians so that your answers are always in radians when you're working with circles, angles, and angular movement. Now, 139, same thing. We're going to say that multiply by pi over 180 degrees. And the answer, I already had the answer there. It's 2,37. Please write down that radians. So put your answer in radians. Great. So even this type of questions there, it will be 1 mark because we're just using a calculator there. We're just saying 214 multiplied by pi over 180. Please don't confuse the two, the pi over 180 and the 180 over pi. Okay, 180 over pi is when we're changing from radians to degrees. Pi over 180 is when we're changing from degrees to radians. So it's 1 mark. It's just 1 mark. Okay. Remember, the parts of the circle, you've done this in grade 9 and somewhere in grade 8, where you in grade 9 specifically. Grade 10 also, you've done some parts there of the circle. Very important that you understand these parts of circles, because when we are doing questions, exam questions, they just talk about the sector, they talk about the chord, they talk about the diameter, talk about the radius, they talk about the tangent. So you need to understand what is a chord, where is the chord, how do we draw a chord, how do we look at a sector, how do I look at the segment, where do I get the segment, where do I get the sector, where do I get the arc length. So these are just parts of this circle that I've put in there so that we just remind ourselves about this. Now here we have got a chord here. You can see there's a chord from one part of the circle to the other part of the circle without passing through the center of the circle. So this chord does not pass through the center of the circle. There's a diameter. The diameter, it's a chord. It is a chord because it's from one part of the circle to the other part of the circle. It's a special kind of a chord. Why? Because it passes through the center. So if it's a special kind of a chord, we no longer call it a chord, then we call it a diameter. So we give it another name. So a diameter, it is a chord. It's a special kind of a chord, but it passes through the center of the circle. That's why we give it a separate name. Now we have a radius, which is half of a diameter. We have that radius. We have that arc here, of which there we're going to call it S. So we're going to call it an arc length. So there we're going to call it an arc length. So you see from here right around there, it's our arc. So it's our arc length there. So if I put the letter S, you must know we're looking for the arc length there. So that part here, it's going to be our sector, you know, sector, it's that part that is bound by the diameter. So the radii. So the two radii will then form a sector. So we have a sector. You'll see when we're doing the area, we'll say calculate the area of that sector here. Okay. Right. So now we have that part there will be the segment there. The minor segment, or what do we call the segment there? That is called a segment, and it is a minor segment. That whole part, the bigger part there, will be the major segment. So the segment will be created when we have a chord there. So a chord will divide the circle into two segments. So we have a minor segment, which is a small segment, major segment, which is a big segment that is left by the chord. If we have got a diameter there, you'll realize that there we have a semicircle. So the other part it's half of the whole circle. Okay, right? There we have a radius. There we have a radius. Okay, we know the radii are equal. If I'm given that one is 4 centimeter, that will be 4 centimeter. There we have a central angle because it is at the center. So we call it a central angle. So the terminology that you are going to get in questions, sometimes they'll say the central angle is given S. Then you know that's the angle that they're talking about. Okay, so this is the parts of the circle that we'll be working with. The tangent here, you can see that line there touching the circle at only one point. That is a tangent. The secant here, we can see it touches the circle at two parts and also continue on the other side. So you see the difference between the secant and the chord. See, the chord is from this part of the circle to this part of the circle. That is a chord. Right. Now, to the activities. Before the activities, we have the formula that are going to be used for parts of the circle. For parts of the circle here, we talked about the S, which is going to be the arc length. We say, when do you use it? Finding the arc length of a circle given the radius and the central angle. You remember I talked about the central angle? That is what we are going to be looking at. So the S will be the arc length. So you need to find the arc length. The radius must be given, the central angle is given, and that angle here must be changed to radians. Change to radians. Right. So now you realize that, oh, okay, now we're working with this circle, so that part must be changed to radians for us to find the central angle. To find the arc length, sorry. Right. The circumference is equals to 2 pi r. That is calculating the circumference of the circle when you're given the radius. So if I'm given the radius, I will be able to calculate I only need a radius. If I've got a radius, I can calculate the circumference. Remember, circumference is nothing else but the perimeter of the circle. So I can be able to get there. So the area equals to pi r squared. You know that formula, it is for calculating the area of the whole circle. So if I'm given the area of the whole circle, I can be able to calculate r. But if I'm given the r, I can be able to calculate the area. So you just need the r. You just need the radius to calculate in a circle. The circle is nice because you don't need a lot of stuff there. Finding the area of the sector. Remember I talked about the sector. You must be given the central angle, right? And you must also be given the radius. So if I've got a central angle and I've got a radius, I'm able to calculate the area of the sector. Or I must be given the arc length. If I know the arc length, which is S, I can be able to calculate the area of the sector. So those two formulae. So it will depend on what is given in your question. If I'm given a central angle, I'll use that formula. If I'm given the arc length, I'll use that formula. And I've got a nice question on this. Okay, so you realize that that formula, how from this formula here to that formula, how can I go to that formula? This is not for exam, but just to show you how we get to that formula. If I've got A equals to half S multiplied by R, I know that my S from this formula, it's R multiplied by theta and multiplied by that R. Then I'll have half R times R, it's R squared multiplied by theta. So you can see that formula here, it's nothing else but that. So they're the same. We're just replacing the S, which is the arc length, by that, and we get the formula. So, but this is not for exam. They won't ask you that question in an exam. But just for you to can see that those two formula are the same. The last formula there that we're going to use for today, it will be to calculate the height of the segment, or the chord length, or the diameter. We talked about all those things. The height of the segment, the chord length, and the diameter. So the H stands for the height, the D stands for the diameter, the X stands for the chord length. So all those three. So the height will be represented by H, the chord length will be represented by X, the diameter will be represented by D. Can you see we have all those three? So in other words, you must be given two things for you to can calculate the third one. If I'm given the chord length and the diameter, I can calculate the height. If I'm given the height and the chord length, I can calculate the diameter. So I can be able to calculate that. So let's see how we use this formula. The first thing, the first activity. Determine the arc length of a circle with a radius of 10. You see, I'm given the radius. That subtends a central angle of 70. You see, I'm given the central angle. So the central angle is given. The radius is 10. So I need to calculate that. So the formula there in the formula sheet. Please, you must go to your formula sheet and check those formula. Nice thing about this section is that those formula are written there and they are explained what that formula is for. So here, what is my formula? S equals to R multiplied by theta. Do you remember what you say about the angle? We must change the angle to radians. Otherwise, we are not going to get the correct arc length. Now, some of you will put an angle there, and at the end, then they change everything to radians. Let's check with this one. So the radius there is going to be 10. The angle there is going to be 70. But how do I change degrees to radians? So do you still remember how we change the degrees to radians? We multiply by pi over 180 degrees. That's what we do. Okay, so therefore, we're going to have, if I take my calculator out and say 10 multiplied by 70 multiplied by pi over 180 degrees, then I get 12,22 centimeters. I must write my units correctly. That's my final answer. The length of this side there, it's 12,22, which makes sense because the diameter is 10. That length can be 12,22. You see? So if you don't change that to radians, the degrees to radians, then that's where you're going to get 10 multiplied by 70. And if you take 10 multiplied by 70, you are going to get 700. So that length cannot be 700 centimeters. So you see, and that's where then you can say that is now going to multiply by your pi, then divide that by 180 degrees, and your answer there becomes 12,22. So if I do it the other way around, I can then say, but I think this method will be much easier. But some of you might go S equals to 10 multiplied by 70 degrees. Then the answer that they get there is 700. Then you take the 700, you multiply by pi over 180 degrees. Then you are going to get your 12,22 centimeters. You see? So you can still do it that way. This is 3 marks. Nice thing about this section is that you are given a mark for a formula, a mark for substitution, a mark for the final answer. Okay, so with even this one, you're still going to be given a mark for the formula, you're given a mark for the substitution, and a mark for the final answer. So there will be 3 marks, 3 easy marks. All right. The next activity there says a central angle theta. So the sketch is not given, but we know that the central angle theta in a circle with a radius of 4. So what is given here is a radius. It's subtended, very important, it's subtended by an arc length. So in other words, I have a circle which is subtended by the arc length of 6 centimeters. So what is given here? The A says you must determine the measure of theta in radians. You see now they want it in radians first. So how do I calculate that in radians? So I write down the formula. Substitute. The arc length, S is the arc length. So the S is given. So which is 6 centimeters. The radius is given is 4 centimeters. So there will be 4 centimeters. That's multiplied by a theta. Right. So now, how am I then going to get? Remember, this theta is in radians. So it means that the theta will now become 6 over 4, which is going to be 1,5 radians. Okay, so the theta that is in that formula is in radians. So I'm going to get that answer in radians, which is 1,5. So it cannot be degrees. So that will be, that you must note there. So the mark will be for the formula, the mark will be for the substitution, the mark will be for the final answer. That's 3. Now they say, then determine that one in degrees. I've already calculated that in radians. What should I do? Just change that to radians. So I've got 1,5 radians. I want to change them to degrees. What should I do to change them to degrees? Remember, it's going to be 180 degrees over pi, which means that now in degrees there, it is going to give me 85,9 degrees. Let me quickly check again. So there will be 1,5 multiplied by 180 degrees, and then divide that. Okay, 1,5 multiply by 180, then divide this by pi. So the answer will be 85.9 degrees. Now it's in degrees. Okay, so now I've changed my answer from radians to degrees, because the answer was in radians, change it to degrees. And that is just the multiplication, so it's only 1 mark. Okay. All right. Nice question. Okay, now let's get to this question now. Yeah, this is also an exam question. Very nice question. First of all, I must then look at what is given. What is given is a central angle, which is 60 degrees. Nice. And OD, it's 5 centimeter, that's given. But OD and OC are equal. So this is going to be 5 centimeter also, because they are a D. Now the question says, determine the arc length. So the arc length, here we've got two things here. We have a chord, CD, and I've got the arc length, CD. So you see here they're talking about arc length of CD in centimeters. So the two things are there. So on CD, we have got an arc length, we have got a chord. So here they're looking for the arc length. So how am I going to get the arc length of that? So remember, the arc length is going to be S equals to R multiplied by theta, of which a theta must be changed to radians. Then I'm going to have my R. My radius is given there, it's 5 centimeters. That question there should be 3 marks, sorry. Right? So now I need to change my 60 degrees to radians, which is pi over 180 degrees. Right? Now I need to find the answer there. My answer is going to be 5,24. Most of the time you'll find that, you'll realize that the arc length is bigger than the radius. So this arc length is 5,24, which is longer than the radius. Right, so I've got that answer there. Moving right along. Determine the area of the sector. Now we need to determine the area of the sector. So the area of the sector is the whole shaded area there. Can you see the whole shaded area? There's the sector. Right. So how do I find the, so they say leave the answer in radians to the nearest integer. So now how am I going to find the area of that sector? So already in that last question, I have the arc length. So which formula should I use? I also have an angle. I can use an angle. But now, if I use the arc length, I might have got the arc length wrong, which means that then I'm going to get the next question wrong because I'm using something that is wrong. So it means that the easier way to do it is to use the angle, because the angle is already given there, you see? So I can go find the area is equals to half of r squared multiplied by theta, because the angle I have, the radius I have. So I have the radius, I've got the angle. Still, you can use that formula, A equals to half of r multiplied by s. But now with this formula, if my s is wrong, then the whole that other part is going to be wrong. So to be safe, let's use the formula that I have that have values given. So I'm going to have half. What is the radius? The radius is going to be 5. So it's 5 squared. Multiply by the angle. The angle is given. Remember, I must change the angle to radians, which is going to be pi over 180 degrees. Then my answer there is going to be 13,1. But they said this must be to the nearest integer, so that will be 13. So my radius is going to be, my area is going to be 13 square centimeter. Remember, we could talking area here. If I use this formula, it will be the same. I'll have A equals to half. The radius is 5. Remember what I got for my arc length was 5,24. Then if I multiply that, I'm going to get 13,1, which is to the nearest 13 square centimeters. So I can be able to get this answer. This answer should be the same. But as I said, let's be safe. Use the one here where you have all the values given on that sketch. Then I know that I am correct. Okay. C states that determine the length of the chord CD. The length of the chord. Remember, I had a formula for the length of the chord, but that formula need me to have the diameter, which I can get by using the radius, and need me to get the height, and of which I cannot get the height here. But let me make a plane. Remember, I said here it's going to be 5 centimeters. This line and that line are equal. Great. I love that. If those lines are equal, it means that these two angles are going to be equal. Remember, angles opposite equal sides. Remember, now we're integrating the geometry that we have done in grade 9 and grade 8. So we say these two sides are equal, which means that these two angles will be equal. So already I've got 60. I need 120. And out of the 120, these two angles must share. So if they share, it means that that will be 60. That will be 60. Oh, now what do I have? An equilateral triangle. This angle, that angle, and that angle are equal, which means that all sides must also be equal. So it's 5 centimeter, 5 centimeter. Obviously, that will be 5 centimeter. So the length of this chord here will be 5 centimeters. Okay. So now the reason there, remember, it is that angle and that angle will be equal, and it is an equilateral triangle. In an equilateral triangle, all sides are equal. All angles are equal. Therefore, side CD will be 5 centimeters. Okay. So we did not need a formula to do that. We just needed to look at that question and apply our Euclidean geometry knowledge to do that question. Right. And it says hence. So hence means I know that this is 5 centimeters. That's 5 centimeters, obviously. So it says hence. So hence meaning that use the answer that you got in the previous question, which is C, where they said calculate the length of CD. Now we need to determine the height of the segment. Nice. Between the chord. So you see, between the chord CD and the arc CD. In other words, I need the height of this. I need the height here. I need the height. So how am I going to calculate the height? So remember, if I've got a chord, I need to find the height. I can do this. So I'm going to say, now the formula that I'm going to use now will be 4h squared minus 4dh plus x squared equals to 0. Now remember, now I need the height. So h I don't have. The diameter I have. What will be my diameter? I have 5 as my radius, meaning that the diameter will be 10. I don't have the height. I have got the length of the chord, which I know it's CD, so I've got 5 squared equals to 0. So I'm going to have 4h squared minus 40h plus 25 equals to 0. Then I solve for h. So I can use the formula here, my quadratic formula. The b is going to be minus into minus 40, which is 40. Then I'm going to have plus minus the square root of 40 squared minus 4 into 4 into 25 and divided by 8, because that will be 4 times 2, which is 8. So the h value, if I use my calculator correctly there, I'll have 2 values here. The other one will be 9,33 centimeters, or the other one will be 0,67 centimeters, correct to 2 decimal places. But then I realized that this height, this small height there cannot be 9. So it cannot be that. So then the correct height of this, it's going to be 0,67 centimeters, because that's a very, very tiny space between your chord and your arc. So choosing the correct answer will be, so you have a mark for the formula, mark for substitution, and mark for writing for that, and then the mark for this, and mark for choosing the correct one. Okay. All right. Now, let's look at activity number 4. This is a nice activity there where we included almost everything that we needed. You know, your arc length, you know, your including geometry stuff, and you know your height of the segment, where we included the diameter and also the length of that. Now, activity number 4. A sprinkler head is set to irrigate only a sector. You see, that sprinkler needs to irrigate only this part, which is 25% of the whole circular garden. So the whole circular garden, the degrees there, because we need the angle there, it will be multiplied by 360 degrees. So in other words, it's 25% of the whole. So the angle there will be 25% of the whole. But now look at this. Calculate the size of FOG in radians. You see, now they know you're going to get it in degrees. Then we need to change it to radians. Can you see that conversions is very, very important? Now, FOG, so we're going to say 25% of 360 degrees. So that's what we're going to get. We're going to get that angle FOG. But that FOG is in degrees. That what we're going to get there is in degrees. So I'm going to say 25% of 360 degrees, 0.25, multiplied by 360, and that's 90. So my angle that I'm going to get there is 90 degrees. But now I want it in radians. What do? I'm going to then multiply this by pi over 180 degrees. Then I'm going to get that in radians. So in radians there, I'm going to get 1,57 radians. Okay. So the 3 marks there is for writing that. The other mark is for changing this, and the other one is for the final answer. Okay. Now I know that that angle that I'm going to be working there with there, it's 90 degrees with a radius of 6,95 meters. Okay. The next question says calculate the area of the sector that is irrigated. So the only area that is irrigated is this part here. So that's the only part that is irrigated. So I've got the radius, I've got the angle here, my angle there, it's 90 degrees. So meaning that the area that is going to be irrigated will be that. So I'm going to use the r squared multiplied by the angle. Because I have the angle, I have the radius. So I'm going to have half of my radius is 6,95 all squared multiplied by the angle, which is 90 degrees. But remember now, this angle must be in radians. I already know the radians. Can you see how we then use whatever we got previously? So I already have the radians, which is 1.57. So now I don't need to say 90 multiplied by, I've already done that. Then what do I get? I'm going to get 37.92 square centimeters or square meters. So in other words, the area that needs to be irrigated, it's 37.92 square meters. So I need to irrigate, that sprinkler will only irrigate that area, and I got that area, which is 37.92 square meters. Interesting question. Okay, we are moving nicely. Right. Interesting question that in most papers, I see it in most papers. A lot of papers, they use this type of questions, and most of the time we don't get it right. And why? I don't know, because these questions are so straightforward. Now, let's look at this one. It says the diagram shows a motorcycle drive belt that uses 3 pulleys. You can see pulley 1, pulley 2, and pulley 3. I know, because there's a lot of things that they put there, that story there. So we need to put this information on the sketch. Most of the information is already on the sketch. The radius of the circle A, so the circle A there, it's 5 centimeters. So in other words, I have the radius of that circle there, it's 5 centimeters. And the measure arc subtends a central angle of 210, which is there. You see, the angle there is 210. So meaning that if I've got a radius, I've got an angle, central angle, I can be able to get the arc length. You see, I can get the length of that belt on the pulley. The area of the shaded sector in this one. So the area of this one is already given is 54 pi. Okay. The largest circle has got a radius of 9. So in other words, the largest circle is this one. So it's got a radius of 9. So the radius there is given as 9. The length of the rubber belt is 140. So the length of that belt, the whole belt is 140. From there, remember this is our belt. So it runs through, it's 140 centimeters. The first question there, it says, convert 210 to radians. Easy question. Remember what we've done a lot of questions on this one. So how do I convert 210 to radians? So I'm going to say 210 multiplied by pi over 180 degrees. And the answer that I'm going to get there, it's going to be 3.67 radians. Okay, you can write in decimal or you can write it as a fraction, you can write it with pi, not a problem. So you still get a mark for that. So it's only 1 mark. Okay. The next question says hence. So in other words, whatever we got there, we're going to use it in the next one. Now it says, now calculate the length of the measure arc BC. So the length of the measure arc BC. Right. So how am I going to get the measure arc BC? So remember, I already have the S equals to R theta. I already have my theta. I already have my diameter, my radius there. It's 5 centimeters. So the central angle is 210. So how am I going to get it? So I'm going to say I already have theta in radians in the previous one that I've done. Hence they say use the previous answer that you got. So what is my radius? It's going to be 5. What is my theta? It's going to be 3.67. Then what will be the length of that? 18.33 centimeters. So the length of that belt there will be 18.33 centimeters. From B to C, it's 18.33 centimeters. That's the length of that belt there. Okay, so it's 1 mark for that, 1 mark for that, 1 mark for that. So I've got 3 marks there. Okay. Right, now the next question, still on the same one here. It says calculate the size of theta in the largest circle with center D. Remember here the area is given here as 54 pi. Love that. The radius there is given as 9 centimeters. So what is given there? I've given the length. The area. I'm given the radius. Now they need the angle. In the next 2 minutes, I want you to do that question. In the next 2 minutes. I'm only giving you 2 minutes. Let's make it 3 minutes. Let's make it 3 minutes to do that question. Then I've given you an idea on how you're going to do that question. 3 minutes is what you have to do that question. Okay, now let's see what you have done. The question says calculate the size of theta in the largest circle. So in other words, we have a theta here. Here's an angle. You can see it's more than 180 degrees. So that's a guide to say whatever you got there, it must be more than 180 degrees. Okay, So, and they did not say whether you have to calculate it in radians or you have to calculate that in degrees, so you can put your answer in any form. But I'm going to calculate it in degrees, and let's see if that angle is more than 180 degrees, but I'll also write the answer in radians. Now, first of all, the area is given, the radius is given. So I'm going to go to a formula that talks to the area of the sector. So the formula that talks to the area of the sector is A is equals to half R squared multiplied by theta, because that's what I'm going to be looking for. I cannot use S because the arc length is not given. The area is given. The radius I've got, I only need the theta. So what is my area? So the area is 54 pi. The radius is 9 squared. Then I need the angle. So now, how am I going to get the angle here? So the angle that I'm going to get will be theta, it's equals to. So I'm going to go 54 degrees, 54 pi, 54 pi. Then I'm going to divide that by 0.5 multiply by 9 squared. Okay, so the angle that the value that I'm going to get there, it's going to be 4 over 3 pi. So my answer there is going to be 4 over 3 pi. Or I can write my answer as, I'm going to write all here. I'm going to write my answer as 240 degrees. Or I can write my answer as 1.33 pi radians. See? So my answer will be 240 degrees. How do I know I'm correct? It is because that angle is more than 180 degrees, so it could be right. Okay, so that's why I've written it in degrees also, so that you can see that that answer is partly right. So 1 mark for the substitute, for the formula, 1 mark for the substitution, 1 mark for the final answer. So that's 3 marks. Okay, so choosing the correct formula is very, very key in doing this type of question. So you must have your formula sheet every time you practice this type of questions. Have your formula sheet in front of you, know which formula to use where. Okay, so area is given, go to the formula where we have area. Eliminate all other formula for the sector of this, the area, the sector, the arc length. Then use the formula for area. And that formula for the area, it's relevant because the sector, it's the one that is shaded that you're looking for. Okay. D says, determine the length of the chord EF. So I go to my chord EF, I look for EF, EF is there, so that is the length of the chord. So if they talk about the chord, then you remember that you have a formula that you use for the chord length. For the diameter, there's a diameter, there's the height. So I need those two things. So if I put my formula down and let me check what I'm going to have. If I've got my formula there, it's 4h squared minus 4dh. Make sure that you copy this formula correctly, because we have instances where this formula is copied incorrectly, where the plus sign is where there's a minus sign and the minus sign is where there's a plus sign. Please make sure you copy it correctly. So it's 4h squared minus 4dh plus 8x squared. What is my x? It's going to be my length of the chord. What is the height of that? So remember, I need the height. I've got a height here from here to there. Remember, that's your height. So I've got a height there of 7. Sorry, the height there of 7. Because remember, the whole thing is going to be my radius. So meaning that this part, because this is your chord here. So the height of that comes there, and then that becomes the height. So the height of the chord we have it's 7. We have the diameter, we can then have a diameter because we know that our radius is 9. So if I know my radius is 9, the diameter is just times 2. So for my height it's 7. My diameter is 9 times 2. Great, that's 18. I love it. My h it's 7 because I know that's my height. Then what I don't have is my length of the chord. You see? So for this formula for the use of this formula, we have already calculated h, so you know how to calculate h. Now we need to calculate the x. We are calculating the x. What is key here is now how to find the value of x. Now for me to find the value of x, then it means that everything else there must go to my right hand side. So I'm going to have x squared, it's equals to. So it's going to be 4 into 18 times 7. Because that was minus, it goes that side, becomes negative, positive. And then I have minus 4 into 7 squared. Then I need the value of x, which means that everything there must be inside the square root. I'm just doing it the long way here. Okay, it must be inside the square root. And then I'll have the value of x. Remember, it is the length of the chord. We can't put a plus or minus. So it's the length of the chord. So the length of the chord will be positive. So now, if I do it on a calculator there, I get 2 square root of 77. Or I can write this as 17,55. Remember, this is in centimeters. So in centimeters, so I must always write down the units. So it's 17,55 centimeters. So the length of that whole chord there will be 17,55. The other way of doing it could be, what can I do? I have a triangle here. I have this triangle here. I know that the length of the whole length there is 9, meaning that this part here will be 2. Because that part here is 7. So 7 plus 2 will be 9. So I'll have a 2 here and 9 there. So in other words, I can just take out this triangle here. So the triangle will look like this. Will look like this. So we'll have a 2 there, we'll have a 9 there, and I'll have, I'll have a 90 degrees there. So I can use the theorem of Pythagoras to get that side, which is going to be EG. Okay, so I can get that length by using the theorem of Pythagoras, which is going to be 9 squared minus 2 squared. Then I can get that length. After I get that length here, I can then multiply that length by 2. Okay, so because there is the same thing will apply there. This is 9 and there is 2, I can get that length. So it's the same as multiply that length by 2, and the answer that we'll get will be closer to 17.55. Remember, you'll have rounded off most of the stuff. Okay, right. So you can then go and try it by using the theorem of Pythagoras to get that length. Remember, this is 90. Get that length, and then you'll be able to get the length of EF. So many ways of doing it. All right. Okay, JK. Now we are given JK here. It's 4,19. Already I know the EF there. I can get EF from E to F here. I can get that one. Already I know that one. So you can see all the parts that I've indicated in red are not needed in this question because it says calculate the length of the bell that is not in contact with the 3 pulleys. So these parts here are in contact with the pulleys. This part is in contact with the pulleys. So I know that the other one there that I got was 18.32, 18.32. Got it, remember I got the length of EF. Then the one that I need now, it's this one. I haven't calculated this one, remember? I haven't calculated it. This one I have, that one I have, but I need that part. If I can get this part, then the length of the whole belt, remember, it is 140. So the length of the whole belt is 140. So I'm going to remove this part. I'm going to remove this part. I'm going to remove this part. Then I have the length of the belt that is not in contact with the pulleys. Okay. Hope that is clear. And it's 5 marks. First of all, I must first calculate the EF there. So here I must first calculate that arc here. So how do I calculate that? It's going to be S equals to R multiplied by theta. Okay, so I need the arc length. Or I can use the formula of area because I know that the area of that is 54 pi, of which the formula will be A equals to half RS. I can use the RS because then I'll calculate the value of S. That I know it's 9. So now, let me use this one. So the radius is 9. The theta is going to be, remember I got the theta, which was 4 over 3 pi. Right. So I'm writing it in radians already. So the answer that I'm going to get there is 37.70 centimeters. So what is this? It is this arc length from here to there. So it's 37.70. So I have that arc length. So what should I do with that arc length? I must remove it. From how much? From 140. So I have the whole belt as 140. So remember in that question it says the whole belt is 140 centimeter. So now what should I do now? I must say the length of the rubber belt, will be equals to 140. That is not in contact. Remember, it is not in contact with the pulleys. So the whole length is 140, but I must subtract what? The one that is on the pulley, it's 18.32. The other one that was given that is on the pulley, it's 4.19. And the other one that is on the bigger pulley, which is 37.70. Okay. And that I'm going to be left with the length of the rubber that is on there, that is not on the pulleys, on the 3 pulleys. Okay. So 140 minus that, if I use my calculator correctly, then I'm going to get 140 minus 60.21. Then the answer there is going to be 79.79 centimeters. So the length that is not on the pulleys, it's 79.79 centimeters. Lovely question. Please practice these questions. And I know in this question, can you imagine in this question if it was just one question of 10 marks to say calculate the length of the pulley? But in the exam, what they do, they break down this question nicely so from A to E. So you can see from A to E, we're trying to get all the things that we need to do E. So for E, I have that I already got. This nicely it was given that I needed to calculate. So therefore I'll be able to can do that. Okay. All right. Now activity 6. I'm going to give you 3 minutes to do activity 6. That's very, 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 it's a very easy question, the activity 6. I'm going to give you 3 minutes to do activity 6, and then we'll continue from there. Okay, now the question states that calculate the area of the shaded sector A or B. And please, you can send your solutions to 063 629 3655. And WhatsApp your solutions to that number, 063 629 3655. Right, calculate the area of the shaded sector A or B. Now, that part is the shaded area. Okay. Now, first of all, the other way of doing it is to first change the angle. So in this question, I'm going to first change the angle. All right. So I'm going to say 180 degrees, 130 degrees multiplied by pi over 180 degrees. So now I'm changing my angle to radians. So after I've changed my angle to radians, so I'm going to say that's 130 multiplied by pi over 180 degrees. So I'm going to get 2,26. Okay, right. Then I'm going to say the area, it's equals to half r squared times the angle. Remember, as I said, that will be in radians. So I'm going to have half, what is the radius? 9 centimeters squared. Then I'm going to have multiply by, my radians is going to be 2,26. I've already multiplied that. So remember to keep the whole, all the decimals so that you don't round off everywhere. Then I'm going to take that and multiply it by, okay, let me just do that and multiply that one by 9 squared, and then multiply this by half. So the answer that I've got there, it's going to be, if I'm not mistaken, there it's 91.1. 91.1 0.89 square centimeters. So I'm going to have that as my final answer. So the area there is going to be half r squared multiplied by the theta. The theta is in radians. So I already changed that to 130 to radians. Then multiply that one, square the 9, and then from there multiplied by half. Then my answer will be there. So remember, I round off at the end, which is 91.89. Very important. And when we put the answer there at the end, remember it's area, so it must be squared units. So if it's centimeters, that will be square centimeters. If it's meters, it's square meters. Okay, so that answer is in radians, so that's how we get that. Because remember, if I use the degrees in this one, then the answer is going to be very big. Then I can change it at the end. It does not matter. If I use the angle, remember you must change it at the end. Don't forget to change it at the end, because then you'll not have it correct. So the first mark, in this case, the first mark there, it will be the formula, correct substitution, and then the final answer there, 91.89. So that's area. Okay, now let's look at activity number 7, which is going to be our last activity. Now here we have got a wall clock. This is a very big wall clock. You'll see when we're doing the answers there. A wall clock has an area of 452.39 square meters. Now here we're talking meters. So you can see the conversions are very important. Also, you must know your meters and you must know that. Sometimes they must give it as meters and they say find calculate maybe the area in centimeters. So you must know how to change those meters to centimeters, or they must change it from centimeters to meters. Okay, determine the diameter of the clock in meters. First of all, I only have the area of the clock. So in other words, I've got the area of a circle. So you see, I've got the area of the whole circle. I know most of us in this case we struggle with this type of clocks, and then we are so used to the analog ones now, to the digital ones. So this analog one, determine the diameter of the clock in meters. So let's see how we're going to do that. There's nothing that has been given. We don't know what is the radius. We don't know what is the diameter. We only know what is the area. So what is the first thing that I'm going to do? I'm going to find a formula that has got an area. Remember, with the circles, it's very easy. The circle, you need a pi, which is a known value, and you also need the radius. So if you remember the formula for the area, so the formula for the area is A equals to pi r squared. See, so I've got the pi, which I know. I've got the r, which I don't know. What is the relationship between the r and the d, the radius and the diameter? The diameter is twice the radius, and the radius is half of the diameter. So if I know what is the radius, then I'll know what is the diameter. So what is my area there? So my area is going to be 452.39 square meters. I've got pi, I've got r squared. So how do I calculate the r squared? So I'm going to say r squared equals to 452.39 all divided by pi. Then my r squared is going to be 144.000. Okay? Right. I use my calculator correctly there. Right? So the r will be the square root of that value, which is 144.000. Okay. Then the answer there of r will be 12. So remember, it's in meters. Am I done? No, the question needs a diameter. So I need a diameter for that. But I've got a radius, which will make that an easier question. So therefore, the diameter will be equals to 24 meters. So I've got a diameter of 24 meters. So I've now answered the question. So the question was find the diameter of the clock in meters. So it means that the diameter there will be 24, meaning that my radius will be 12, my radius will be 12, my radius will be 12. So that radius will be 12. So the r I have now, it's 12. The d I have. So now what do I need? In the next question, it says, hence, you see, hence means use what you got in the previous question. The previous question, I got r, so I'm going to use my r. So my r is going to be 12 meters. So I already have my r. Now they say calculate the area of the shaded sector. So the shaded sector is this part here. So you see that part there, it's shaded. But if it's 3 o'clock in this case, what will that mean? It will mean that that angle that is from there will be 90 degrees if it's 3 o'clock. I mean 12, 1 up to 12, and 12 you divide them into 4 quarters, then you have your 90 degrees there. So it's 360 degrees divided by that. So if I can do this here and do that there, can you see this is 90, that's 90, that's 90, that's 360 degrees at 3 o'clock. Because that will be 3. So 1, 2, 3 again, 1, 2, 3 here, and then 1, 2, 3 there. So we have 4 quarters there. Okay, so there will be 90 degrees. So already I've got an angle. My angle is 90 degrees. I've got my radius, which is 12 meters. So now I need the area of the shaded. So first of all, I must change my angle to radians, which is going to be pi over 180 degrees. I think this we've done it somewhere, which gave us 1.57 radians. So for me to find the area now, I need to use the angle. So to use the angle there, so the formula that uses the angle is half of r squared multiplied by the angle, of which the angle will be in radians. And I've already changed my angle to radians. So now I'll have half into my radius, it's 12 squared, multiplied by the radians, which is 1.57 radians, and the area there will give me a 113.09 square meters. So the area of that will be 113.09 square meters. If you want to check if we are correct, it means that if the area of that is 113, this area will be 113, this one will be 113, that one will be 113.09.09. Then you can add all those ones and then you see if you've got the area which was given, which is 452. So if I take my calculator there and add this, so 113.09 multiplied by 4 of them, it will give me 452.36 degrees. I mean, 0.36 square meters, which is the area of the whole clock. So I think I am correct here. And that one was the last question. Very, very nice question. And thank you so much for doing this with us. And next week we'll be continuing with the circles, angles, and angular movement part 2, where we're going to do the angular movement, angular velocity, and circumferential velocity. So keep practicing. Thank you so much.